Okay, welcome to Solving Trig Equations Part 2. In the last video, we did 3 equations, and we did sort of maybe the more basic ones. We're going to do 3 a little bit trickier ones, but actually what you're going to see is if you know how to solve equations and you know some of your basic trig stuff, these are not going to be too challenging for you, okay? So the first one we're going to look at is this one. And we said that when we're solving these trig equations, we're trying to get the trig function all by itself. And you can see that one of the methods that we used before was actually combining them together. But we can't actually combine these two because they aren't like, because one is squared and one is not. So when I'm looking at this one, I want you to think about, oh, that's not what I meant. I want you to think about it like this. I'm having a hard time. This is what I want you to think about. This and this are basically the same thing. We're going to solve them in the same way. So this one, when you look at this one, hopefully everybody says, oh, I know what to do with that one. It's a quadratic. I'm going to try to factor it. If I can't factor it, then I'm going to use quadratic formula or completing the square. But on this case, I think everybody would know to at least try to factor it because I have a 1 here and a 2 here, so I'm feeling kind of confident that I could factor it. All right, so I need this one to be the negative and this one to be the positive, so I get a -2 and a +1. So when I'm over here, there's 2 ways I can do it. I can literally use this and say let sine x equal x, or, you know, like you should probably use a different letter, but I use let sine x equal x, okay? And then factor it and solve this thing just like you would. What would you do? You'd set these equal to 0, so you'd get x is equal to 1. And then go back and replace it with sine, right? You could do it that way. Solve it all with x's in it, and then go back. But I think a lot of us probably, after we did this once or twice, wouldn't actually need to take that extra step. So a lot of you probably can, right from here, factor it with the signs right in it, which is usually what I do. Again, if you're having a real hard time with that, go ahead and replace it. Don't be embarrassed about that at all. Just go ahead and solve it the old-fashioned way, just like you would of any other equation, and then stick the signs back in and worry about the trig part afterwards. But I'm actually just going to factor it with the signs because I have a feeling that's what most of you are going to do. So we already know how this factors because we just did it, right? See how these two things are the same? You know, one has a sign and one doesn't, but we used an x instead of sine x. All right, and because of our zero product property, which of course says if I have a product of 0, that one of the factors has to be 0. And if that's true, then I know that one of these things has to come out to be 0. So I'm going to go ahead and solve each of these individually. And by solve, I mean solve for the sign thing. And then I'll go and I'll worry about the trig afterwards. Ready? So I'm going to do 2 steps in 1. Hopefully I'm not going to lose you. I'm going to subtract 1 and divide by 2. And over here I'm just going to add 1. Okay? So we have 2 little equations that we're working with. Now my next thing to do, if you remember from the last video, is to think about what reference angles are going to give us these values. So in other words, what angle would give us a sine of 1, and what angle would give us a sine of a half. I just forget about the sign, S-I-G-N, like the positive or negative for a minute, and I worry about the size. So I'm going to go here and I'm going to take this picture, right, our 2 triangles, our 2 special triangles, and I'm going to find the one that has the ratio of the half, and of course we know it's this one. And now I know that the one that has the opposite and the hypotenuse is the pi over 6. But I know that the solution to this equation is not actually pi over 6 because we have a negative a half. But this gives me the start that I need. So I know that my reference angle is going to be pi over 6. For this one, I don't have, it's neither one of these, right? Because if I have a 1 or a 0, it means it's one of these quadrantal angles. And I'm looking for the one that has the sine of 1. So I'm looking for the y value to be 1. So the only one here between 0 and 2 pi that would work is this one. Okay, so this one's going to be pi over 2. So that's a good start. I know that this one's pi over 2 between 0 and 2 pi. Of course, we know there's an infinite number of solutions. And then the sine one, I want to know where sine is negative. Well, sine is positive here and here. So the place where I'm going to draw my pi over 6 angle is here. And so hopefully you know that that one is going to be 7 pi over 6. And then the other place I can draw it, because sine is also negative here, and this would be 12 pi over 6. So if I go one less than that, then we know that this one is 11 pi over 6. So those are my two angles between 0 and 2 pi. So once again, just like in the last video, if they asked us between 0 and 2 pi, then the three angles I'm looking for are 7 pi over 6, 11 pi over 6, and pi over 2. Those would be my three angles between 0 and 2 pi. If they just said solve, or they said, all solutions, something like that, then what would I need to do? I need to describe all the coterminal angles. And since there's an infinite number of coterminal angles, we do it by writing it a little expression. And we say 7 pi over 6 plus, since the period for sine is 2 pi, right? So to get back to here again, that's my 7 pi over 6. And then to get all the way back there again, that would be another 2 pi. So it's going to be 2 pi. And how many times can I spin that around? Well, an infinite number of times, right? K, where K is an integer. Now, usually we have to write that. If you wrote it on the test, like at the top of the page, or, you kind of just didn't write it, I would probably give you credit for it anyway. But you should write it down at some point on the test so that everybody knows that you know what K is, okay? Now, that doesn't describe this guy and all his coterminal angles yet, so we also have to say 11 pi over 6 plus 2 pi k. And then we need all of his coterminal angles, so pi over 2 plus 2 pi k. So this would be the solutions, all the solutions to this one. I could pick any of those angles and it would work. Okay? Sound good? All right, let's do the next one then. All right. I don't think I left enough space on this paper, so let me stick another one under here. Okay, so let's scroll this up. So now this is the one I'm talking about. Now, what's different about this one and this one? Hopefully you can see this one had both signs in it, and this one has a sine and a cosine in it. Now, I said in my last video, there's two ways to get rid of the trig functions we don't want, or not to get rid of them necessarily, but there's ways to work with them. If I have two different trig functions, like I do here, a sine and a cosine, I can try to convert them all to the same trig function, or I can see if there's some way to group them up and factor them and set the thing equal to 0 or whatever. But I think you can see here that, I can't factor a sine out of each of these, and I can't factor a cosine out of all of these. So doing it the way I did in the last video doesn't seem like a reasonable method to me. So what I'm going to do is I'm going to try to change them all to cosine. And the reason why I'm going to choose cosine is because I know how to change sine squared to cosines, but I don't know how to change just cosine to sine. So the Pythagorean identity will help me if I choose the sine as the thing I'm going to change. If they were both squared, it wouldn't matter which one I choose. I could use the Pythagorean identity on either one of them. Okay? So my first step is going to be to change them all to the same trig function. And hopefully you can see this one looks like he's going to be quadratic-y too. I don't know if you noticed that, but I hope that you did, because my brain was screaming, oh, it looks quadratic-y to me, which means I'm probably going to have to either, quadratic formula, complete square, or hopefully, right? Hopefully, fingers crossed, hopefully I can factor it. All right, so we're going to have -2 cosine squared x plus cosine x. Is that -1 when I bring the 2? All right, now I don't like to factor with the negative in front, so I'm going to divide everything by -1 or multiply everything by -1, whichever way you like to think about it. And of course, when I divide this side by -1, it's still 0, so it doesn't really matter that much. But now, to me, it feels easier to factor. Okay? All right. Yeah, I just don't like to factor with the negative, but you do whatever you like. If you like to factor with a negative, go ahead. All right, so here we go. I'm going to try to factor it. I know I need a 2 cosine x and a cosine x. And remember, if you're having a hard time doing it with the cosines, just make a little let statement, like let u equal cosine x. and factor this thing instead, right? You can do that instead, and then at the end, go ahead and put it back. But if you are able to do it with the cosines, I say go for it. And just, to me, I don't know, it seems like one less step, even though it's not that big a deal to do this. Okay, obviously these have to be ones. This time I need them both negative. So let me just check my smile. So that'll be a negative cosine and a -2 cosine. So that would give me my -3. All right. Now from here, I'm going to make my two equations because my zero product property says that one of these has to be 0 if their product is 0. So I get 2 cosine x minus 1 is equal to 0. And I get cosine x minus 1 is equal to 0. So cosine x is equal to 1. And this one says cosine x is equal to a positive 1/2. Okay. Now I already know, right, one of these is going to be quadrantal, meaning it's going to fall on the axes, and one of them is going to be one of my triangles. And again, I usually have these sitting in front of me, even though I kind of know them pretty well since I've been doing it a long time. But the more you do them, the easier it is to get yourself confused or to get brain dead at some point. So it's easier just to have them written out. So what am I looking for? I'm looking for the one to be the adjacent side. So I'm looking for this angle. So it's pi over 3. So I know that this one, my reference angle is pi over 3. Okay? So I know pi over 3 is my reference angle. I'm going to write it over here. And for this guy, I'm going to look at this one. And cosine is the x's, right? So out of these angles, these angles, which one am I looking for? Well, it's this one. Okay? Now this is where we're going to have to be careful. So it makes a difference. We'll look at what directions I said last time. So I put it this way. So when we do between 0 and 2 pi, we'll do it this way. Which means when I describe that angle, I'm going to call him 2 pi and not 0, because this one means excluded and this one means included. If this had been the bracket in this one, then I would have written 0 there instead. Okay, so it makes a difference. All right, let's go ahead and draw our triangles with our reference angle, this one, being pi over 3, and let's draw it in the right places. So I do know that one of them is this one. It is pi over 3, right? That's one of them. Where else is cosine positive? Way down here. So that one is going to be, well, this would have been 6 pi over 3, so that one must be 5 pi over 3. So pi over 3 and 5 pi over 3. So these are my 3 angles. If this is what I'm looking for, between 0 and 2 pi. Okay. Now, if we're doing all solutions, what do I have to do? Well, I have to do pi over 3 plus 2 pi k, 5 pi over 3 plus 2 pi k, and 2 pi plus 2 pi k, I guess. Or you could just write this as 2 pi k. That's the other way to write that one. It's the same thing, right? You don't actually need to say 2 pi plus that. But, okay. All right, and you'd never have both of these, like it's either going to tell you this one or it's going to say all solutions. I'm just doing it both ways so you can see them both to save, I don't know, to make it easier. So I don't have to do as many videos. All right. All right, here's the last one that I put on the sheet for this video, and then we'll do the last ones on the next video. Okay, I think I have 3 more, so we'll do 3 per video. All right, let's take a look at this one. You ready? Now this one is not one that's easy to change. There's no squares, right? So it's not like the last one that was easy to know I should change the sign to a cosine. Even if I move them both to the same side, there's nothing to factor, so that doesn't seem like it's going to help me. So you know what I'm going to do here? I am actually going to square this one. I'm going to square both sides. Why am I going to do that? Because if I square both sides, then I will have squares, and I can change them to either all sines or all cosines. Now here's the deal. When you square both sides, this is a situation where you could potentially create extraneous solutions, right? Because if you say x is equal to 4, well, that has only one solution, right? 4. But if I square both sides, now you've created 2 solutions that weren't there They weren't both there in the original equation, even though that was mathematically legal to do, right? So this is why the same thing, if I had like x squared is equal to x, I can't just divide both sides by x. This is a no-no. Why? Because this says x squared is equal to x. That has two solutions. It has a 0 and a 1. But if you divide, what you get is x is equal to 0. X is equal to 1. You lose the 0. So you've thrown away one of those solutions that you wanted. So we talked about in the last video, don't divide. No, 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 no. Never divide by the thing that you're trying to solve for because you're going to lose solutions. The trouble is when you square stuff or multiply through by an x, like if the x was on the bottom of the fraction and you multiply through by the x, you can create solutions that weren't there. So we should always check our work, right? And how do you check an equation? You plug it back in. But we all know, let's be real, that doesn't happen every single time, right? We're taking a test. It's stressful. We're doing our homework. We have 50 of these to do. So we don't check every one. But this is one that I definitely have to check because I could have created extra solutions by squaring it, okay? So I definitely have to check because if I write a solution that's not actually a solution, it's still wrong, okay? If I put extra solutions in my answer, it's wrong, okay? Now this one, remember, we have to FOIL. It's a perfect square trinomial, so hopefully you know how to do it without writing it out, but remember that it's really this, right? It's really that. So make sure that you multiply it out that way. It's not cosine squared plus 1. All right, so if I see that, I'm going to be very, very angry. All right. All right. Now, again, am I going to change them to sines or cosines? Me, I'm going to change them to sines because I see this cosine is going to be something that's not going to be that easy to change. So I'm going to change them all to cosines because that's why I squared it in the first place. So I could change them either to sine or cosine. But I'm choosing cosine because this thing is going to be hard to change. I'll have to square it again, and then we're talking about messy, so I'm not going to do that. Okay, now I'm going to get them all on the same side. Well, hopefully you see when I subtract, that's fine. I have a cosine squared minus cosine squared, so I'm going to add it. So that means I have a 2. And that was pretty convenient because if it had been a quadratic, I would have had to, try to factor it or whatever. But this way I can just factor out a cosine. So that leaves a cosine x plus 1 here. Okay. So now I set each of these equal to 0. I'm going to come over here because I'm kind of running out of space. So it'll be 2 cosine x is equal to 0. And cosine x plus 1 is equal to 0. Okay. All right, so this one we see that cosine x is equal to 0, and this one we see cosine x is equal to -1. Okay, so let's take a look. Where am I going to find those ones? Well, it's not going to be, where did I put my triangles? I said keep them handy, and then I put them somewhere. I don't know where I put them. Oh, here they are. We know it's not going to be one of these two triangles. It's going to be these guys. I'm looking for the cosine to be 0 and -1. So I'm looking for the x to be -1 and the x to be 0. So where is the x 0? It's here and here. So it would be pi over 2, 3 pi over 2. And then the -1 is going to be the pi. Now here's the kicker. If you just stop and say, well, that's the ones, right? You could be right, but you could also be wrong. Because the original thing said cosine x plus 1 is equal to sine x. So I got to go back and check it and make sure that all of these actually work in there. Because, sine and cosine don't always have the same sign, S-I-G-N, even if they have the same value, right? Like pi over 2. 1 over, not pi over 2, 1 over root 2. In quadrant 1, sine and cosine are going to have the same value. But in quadrant 2, they actually don't. They have opposite values. So it's always, important to check. So I have cosine of pi over 2 plus 1 is equal to sine of pi over 2. Well, of course, we know that that was a 0, right? So is 0 plus 1 equal to the sine of pi over 2? Well, the sine of pi over 2 is 1. So that one checks out. So pi over 2 is good. I'm going to circle that one. Cosine of 3 pi over 2 plus 1 is equal to sine of pi over 2. Well, this was 0 plus 1. 3 pi over 2, excuse me. So, but we know that sine of 3 pi over 2 is -1. So this one is a no. You see that? This one is extraneous. I'm crossing him out. He's not a solution. Okay, now let's try pi. So cosine of pi plus 1 is equal to sine of pi. Well, sine of pi is 0. Cosine of pi is -1. So this one checks out. So it's only these two. We have to throw him away. Do you see how, because I squared it, I actually created this extra situation where the signs got messed up, right? Because I created that squared situation where it had a negative solution, but when I squared it, but that negative solution wasn't actually in the original equation. Okay? So let's sum up real quick. What did we do today? We factored quadratic form. We changed it to, using your Pythagorean identities. You can use any of the identities that work. And this one, none of my identities worked, so I changed the equation so that I could use my identities. Okay? And of course, these are just between 0 and 2 pi. How would I change them to all solutions at our 2 pi k? Okay? In the next video, we're going to talk about ones where it's not 2 pi k anymore that we're going to add. Okay? So stick around. You're going to love it.